Number one, the terminal side of an angle measuring 14 pi over 5 radians lies in which quadrant? Okay, so because this is in radians, the first thing we're going to want to do is we're going to want to convert it to degrees. And we do that by taking this and multiplying it by 180 over pi. Okay, so what happens is this pi on top cancels with the pi on bottom, and then you're just going to multiply across. You're going to figure out what 14 times 180 is and divide that by 5. Okay, so when you do, you wind up getting 504 degrees. Okay, so this angle is bigger, it's greater than 360. So if you think about the way an angle works, the initial side of an angle starts on the positive portion of the x-axis, and what's going to happen is this is going to open counterclockwise, right? Any positive angle opens counterclockwise. Now, this is going to wrap around a full circle, a full 360 degrees, and then it's going to keep going, right? So we want to figure out how far do we have to keep going until we reach 504 degrees. So basically, what you want to do is if you have a number bigger than 360, you just want to subtract 360 from that. You want to take off a full circle from that angle so you could figure out what angle, on which quadrant we're going to lie in. So I'm going to subtract 360 from 504 degrees, and that's going to leave me with 144 degrees. Now, if you want to think about where 144 degrees falls, doesn't that lie in the second quadrant, right? The second quadrant is between 90 and 180. So 144 would wind up, the terminal side would be right here. So what happens is our angle wraps around to get to 504 degrees. Our angle had wrapped around a complete 360 plus 144 more degrees until we wound up in the second quadrant. Okay, so here the answer would be quadrant 2. All right, number 2. In which quadrant does an angle whose terminal side measures 6 radians lie? Okay, I'm going to actually slide this back a little. Okay, so just like in number 1, they gave us an angle in radians, and if we want to figure out in which quadrant it is, we want to convert it to degrees. Now this time when they gave us radians, there's no pi in it, right? It's just 6 radians, but that's okay. We're going to take 6, and same thing we did up here. To convert to degrees, we're going to multiply by 180 over pi. So this time the pi remains, right? Like if you look in number 1, the pi on top cancels with the pi on bottom. We don't have a pi on top to cancel with this pi on bottom. So when we multiply across, we're just going to do 6 times 180, which is 1,080, over, technically this is 6 over 1 times pi, which is just pi. And then you can plug this in your calculator using the actual pi button. So you could plug in 1,080 divided by pi. And when you do, this is going to be approximately, 344 degrees. All right, so let's think about our quadrants, right? We know first quadrant is between 0 and 90. The second quadrant is between 90 and 180. The third quadrant is between 180 and 270. And the fourth quadrant is between 270 and 360. So let me just write that, between 270 and 360. So since 344 is in between those, we are going to wind up in the fourth quadrant. All right, number 3, determine the coordinates of x, y. Okay, I actually see a typo on mine that isn't on your review sheet. This point right here is supposed to be here, okay? That's where the xy is. So let me just move this point down here. There we go. And we could ignore this one. So this is what we're trying to find the coordinates of. All right, now if we want to determine the coordinates of x, y, we know that x corresponds with, I'm just going to say this, cosine of our angle. I'll leave the angle blank for a minute. And we know that the y value corresponds with sine of our angle. And I'm going to leave a space to put the angle in there in a minute. Now, they give us that this big angle here is 225 degrees. Now, what we're concerned with is its reference angle. The reference angle is right here. It's the angle formed between the terminal side of your angle and the closest way to the x-axis, which is right here, okay? So here's your x-axis, and here's the terminal side. This is the acute angle formed between the terminal side and the x-axis. So let's think about this. If we know that this whole big angle is 225 degrees, don't we know that from here to here is 180? So if we take 225 and subtract off 180, wouldn't that leave us with this shaded reference angle here? So let's do it. 225 minus 180 gives us 45 degrees. So 45 degrees is our reference angle. So that's what we want to put here and here. That's the angle we're working with. We always deal with our reference angle. Now we also have to think about the signs, whether this is positive or negative in the third quadrant. So we know in the third quadrant, tan is the trig function that's positive, not sine, not cosine. So what we have to do is we have to put negatives in front of these. And guys, another easy way to think about it, to get to this point, don't you go back and down. If you go back, that's negative. And if you go down, that's negative. Okay, so that's another way to think of the signs. All right, so basically, we're just going to say negative, right? Bring that down. Well, cosine of 45, you guys have to have these memorized. And I would actually write these on your review sheet. Cosine of 45 is equal to radical 2 over 2. So let's replace that with radical 2 over 2. Okay, then I'm going to take this negative and bring it down. And sine of 45 is also equal to radical 2 over 2. So this right here. Okay, so number 4 is kind of like the opposite of number 3. This time they give us the coordinates and they want us to figure out the measure of angle, of angle theta. All right, well, let's think about this. We know that our x value, right, our x coordinate represents cosine of our angle. I'm going to actually put a parenthesis there. And we know that our y coordinate represents sine of our angle. And you know what? Let me put, see how there's a negative there? I forgot to bring that down. Let me slide that in there. Okay. Now we have to just figure out which angle are we talking about if cosine is equal to radical 3 over 2 and sine is equal to 1/2. All right, so let's take a look at our special angles chart here. Well, cosine is equal to radical 3 over 2. Cosine, radical 3 over 2 at 30. So sine should be equal to 1/2 at that same angle. Look, sine is equal to 1/2 at 30. So we're talking about a 30-degree angle here. So let's slide this in. Okay, now that's not actually our angle. The 30 degrees is our reference angle. We're going to use that reference angle to help us find the measure of angle theta. Now, let's first think about what quadrant we're in. Cosine is positive and sine is negative. Okay, so if cosine is positive, you could write this out. All students take calculus. In which quadrant is cosine positive and sine negative? You could see it's right here in quadrant 4. Okay, so we're working with quadrant 4. You could also say, look, if you go over in the positive direction and then you want to, basically you're going over and down, right? Over in the positive direction and then down. Wouldn't that bring you into quadrant 4? So you could say that as well. Okay, but anyway, we know we're in the 4th quadrant, so let me draw this out. Okay, I'm going to draw an initial side on the positive portion of the x-axis and the terminal side in the 4th quadrant. Now our reference angle is the angle between this terminal side and the closest way to the x-axis. So this right here is our reference angle. Okay, this right here is our reference angle. And we just found that to be 30 degrees. Okay, so this is 30 degrees. What they want us to find is basically the positive angle that starts at the positive portion of the x-axis and opens up counterclockwise and winds up right here. So if we know that this is 30 degrees and we know a full circle is 360 degrees, if we take 30 and subtract it from 360, right, subtract it from a full circle, that'll leave us with, that'll leave us with 330 degrees. Okay, and this is what our angle theta is equal to. Okay, 330 degrees. Number 5, a circle centered at the origin has a radius of 12 units. Okay, so let's draw that out. We have a circle whose center is at the origin and its radius is 12 units. So that means basically from the center to any one of these edges is 12 units. Okay, the terminal side of an angle theta intercepts the circle in quadrant 3 at point M. All right, so we have an initial side of our angle, and we know the angle opens counterclockwise and it winds up over here in quadrant 3. So here's our terminal side, and it intersects the circle right here at point M. Okay, so we don't know the x-coordinate, but we do know that the y-coordinate is -6. Okay, what is the value of tan of theta? All right, so first thing we're going to do is we're going to make this right here into a right triangle. So I'm going to connect this up to the x-axis. Okay, and here's our right triangle. Now, if we know the y-coordinate of this point is -6, it means we went down 6 units to get from here to here. So the length of this side would be 6. And since we know the radius of the circle is 12, right, it says right there, from here to here is a radii of the circle, so I could label that as 12. And we know we're always going to use this reference angle right here to label the sides of our triangle. So the side opposite of it would be over here, which is where the 6 is. The longest side, right, the side across from the right angle, so right here, is our hypotenuse. And the adjacent is the side we don't know, but we can find that. Right, if we know two sides, sorry, I wrote that kind of high. If we know two sides of a right triangle, we can use the Pythagorean theorem to find that third side. So since we're looking for a smaller side for one of the legs, we're looking for either the A or the B. I'm going to call it A. So we don't know A, so A squared plus, and here's one of the smaller sides, so 6 squared equals the hypotenuse squared, 12 squared. Okay, so I'm going to bring down the A squared. We know 6 squared is 36, and we know 12 squared is 144. So if we want to solve for A, we're going to first subtract 36 from both sides, leaving me with A squared equals 108, and then just take the square root. Now, technically, when you take the square root, you're supposed to write plus and minus, but because we're talking about the length of something, we can't have a negative, so it's just positive radical 108. Now, 108 I could simplify, right? I can break that down into, let's see, radical 36 and radical 3. Okay, we want to write that in simplest radical form. 36 is the biggest perfect square that divides evenly into 108. And then since the square root of 36 is 6, we could rewrite this as 6 and bring down the radical 3. Okay, so that's going to be our adjacent side. Now, the question is asking us to find the value of tan of theta. So if you think about SOHCAHTOA. All right, so we know here that tan is equal to opposite over adjacent. So tan of our angle, don't forget that theta symbol, tan of theta equals, now theta is technically, I'm going to put it here, it's technically this big third quadrant angle. Now, because we're in the third quadrant, isn't tan positive? So this is going to be equal to positive opposite over adjacent. Okay, so if we look over here, the opposite would be 6, and the adjacent would be 6 radical 3. And then the only thing I'm going to do here is I'm going to simplify this. So basically, this 6 on top will cancel off with that 6 on bottom. So leaving you not with just radical 3, right? That radical 3 is on bottom, leaving us with 1 over radical 3. Okay, and you can leave your final answer like that. I know some of the teachers taught us how to rationalize the denominator. You do not have to do that on a test. You do not have to do that on the Regents. That's just for extra practice, but this answer right here is perfect. Okay, number 6, the terminal side of angle X in standard position passes through the point -4, 6. Okay, so basically if we had, here's our initial side, right? And our angle is going to open up counterclockwise, and when it does, it's going to pass through this point right here, -4, 6. Okay, so this is where the terminal side would be. Okay, so this is angle X. Okay, they want to know what is the numerical value of cosine of X. So what we're going to do is we're going to take this and we're going to make this into a right triangle. Okay, so here we go. Now, based on what they give us, right, since we went back 4 and up 6, the length of this side would be 4, and the length of this side would be 6. And let's do the Pythagorean theorem to find the length of the hypotenuse. Okay, so we have 16 plus 36 equals c squared. So if you add 16 plus 36, that gives you 52. And then when we take the square root, we want to write this in simplest radical form. So the biggest perfect square that divides evenly into 52 would be 4. So radical 4, radical 13, which would be equal to 2 radical 13. And again, normally when you solve an equation with the square, there's two answers, right? You get plus and minus. But because we're talking about the length of a side, you can't have a negative side. So the hypotenuse is going to be 2 radical 13. Okay, now let's label our sides. If this is angle X, wouldn't the reference angle be right here? So as compared to the reference angle, the side opposite of it is the one with the 6, and the adjacent, the side next to it, is the one with the 4. Okay, so they want us to find the value of cosine of X. All right, so cosine of X equals. Now, first thing, we're in the second quadrant. Remember, all students take calculus. Sine is positive here, not cosine, so we're going to have a negative answer. And then if you think about SOHCAHTOA, okay, cosine, you can see I'm writing it right now, is equal to adjacent over hypotenuse. So let's look at our triangle and plug the numbers in. So adjacent would be 4, and hypotenuse would be 2 radical 13. Okay, and then if we look at this fraction, let's just look and say, well, does anything simplify? Yeah, 4 over 2, doesn't that simplify to 2 over 1? So let's simplify this 4 over 2 to 2 over 1. And you don't have to put a 1 in front of the radical 13. You can just leave it as negative and then 2 over radical 13. Okay, and this is our final answer. Again, I know some of your teachers taught you how to rationalize the denominator. If you want to take it a step further, you can. I'm going to leave it at this. You can leave your answer like this on the test, on the Regents, and you'll be 100% correct. Number 7, if tan of theta equals negative radical 5 over 7 and cosine of theta is less than 0, they want us to find the value of sine, cosine, and cotan of theta. Okay, so the first thing I like to do is write out SOHCAHTOA, because that's going to help us with these. Now, let's first figure out which quadrant we're in, and then we'll worry about labeling the sides. Okay, so tan is negative, and cosine is negative. Now, let's think about this. If we think about our quadrants, right, all students take calculus. Well, we want to know in which quadrant is tan negative, and at the same time, cosine negative, right? Cosine is less than 0. Well, the sine quadrant, would be the answer to that. Okay, this is a quadrant where they are both negative. So we're going to be working in quadrant 2. All right, so let's draw out a second quadrant right triangle. Remember, we always go diagonally out into the quadrant and connect that down to the x-axis. All right, so the angle we're working with is this angle right here, okay? And we know that since tan is equal to negative radical 5 over 7, tan is equal to, look over here, tan equals opposite over adjacent. So the opposite would be radical 5, and the adjacent would be 7. Okay, so if we're looking at our triangle down here, right, if this is the angle we're working with, you could put a theta in there if you would like. Well, opposite of this angle is over here. So this, since radical 5 is opposite, I'm going to label this with radical 5. Okay, and then adjacent means next to. Okay, we know this is the side that's next to our angle. Well, the side that's not the hypotenuse. So this is our hypotenuse, that's our longest side. And this is our adjacent side. Now we know from up here that adjacent is equal to 7. All right, and if we want to find this missing side, we can do a squared plus b squared equals c squared. So we're looking for the c, we're looking for the hypotenuse, the longest side. So if we do a squared, you could use either one of these as a and b, plus b squared equals c squared. Okay, it doesn't matter which one of these you use for a and b. So now, when you square a radical, they just cancel each other out. So radical 5 squared is just 5. And then 7 squared is 49. And I'm going to bring down the c squared. All right, sorry, that's an equal sign. So, all right, when we add together 5 plus 49, that gives us 54. So we have 54 equals c squared. And to get rid of the square on the c, we're going to take the square root. And if we do that to the right side of the equation, we have to do that to the left side of the equation. Okay, so the square root of c squared is c. Now, technically, when you take the square root, it's plus and minus, but because we're talking about the length of a side of a triangle, we only need the positive. So we can break this up into radical 9, radical 6. And since the square root of 9 is 3, we could rewrite this as 3 radical 6. Okay, so I'm going to put that over here on our hypotenuse. Okay, so now that we have our triangle all labeled, now we can find the values of each of these. All right, so let's start with sine. We know sine of theta, if we look up here, is opposite over hypotenuse. And since we're in the second quadrant, right, isn't that the quadrant where sine is positive? So we're going to leave this as a positive answer. All right, so now this is just going to be equal to, let's look at our triangle. So the opposite is radical 5. And the hypotenuse is 3 radical 6. And again, if you would like to rationalize the denominator, which means get rid of the radical in the denominator of the fraction, you can. I know some of you've learned that. Some of you have learned that in your class. Some of you have not. But you're fine to just leave your answer right like this. I'm not going to rationalize any of these, so I'm just going to leave them as is. All right, the next one they want us to find is cosine of theta. Now, we know that cosine of theta, if we look up at the top here, is equal to adjacent over hypotenuse. But in front of that, a over h, we're in the second quadrant. Cosine is not positive in the second quadrant, so I'm going to write negative adjacent over hypotenuse. I'm sorry. Yeah. Okay, so let me bring the negative over, and then in place of adjacent, I could replace that with a 7. And in place of hypotenuse, we can replace that with 3 radical 6. Okay, so there we have it. Cosine of theta equals negative 7 over 3 radical 6. Okay, and then finally here they want us to find cotan of theta. Now we know cotan is a reciprocal of tan. So let's first write down tan of theta. Okay, we know tan of theta is equal to, now since we're in the second quadrant, it's negative. And if we look up here, it's opposite over adjacent. And if we substitute in the opposite, which is radical 5, and the adjacent, which is 7, we get negative radical 5 over 7. Now, I really didn't even have to think about that because if you look up here, wasn't that given to us? Okay, but look, at least we know we're on the right track then, right? All right, so now for cotan, cotan is the reciprocal of tan. So all we do is we take what tan of theta is equal to, and we just flip it right upside down. So because it's negative, it's still going to be negative, but now the 7 will be in our numerator, and the radical 5 will be in our denominator. Okay, so just flip it upside down. So negative 7 over radical 5. And there we go. Okay, so in number 8, we're given some information about tan and sine, and they want us to use that to determine the values of cosine and cosecant of the angle. All right, so let's first figure out which quadrant we're in. So if tan is negative and sine is positive. All right, so let's write this out, right? All students take calculus. All All right, so in which of these quadrants is tan negative? So we know tan is negative here and here. And at the same time, sine positive. Well, sine is positive in the second quadrant, where at the same time, tan is negative. So we're working with the second quadrant. Okay, just actually like the last example. All right, so I'm going to draw a second quadrant bow tie triangle. So I know I go diagonally out into the quadrant, and I connect that to the x-axis. So here's my right angle. And this is the angle we're going to be working with. I'm going to label it A. And if we look up here, tan of A is equal to negative 2 over 7. So since tan is equal to opposite over adjacent, 2 is opposite and 7 is adjacent. Okay, so opposite this angle, across from it, is going to go the 2. And then adjacent to the angle is where we're going to put the 7. And then to find the hypotenuse, we are going to do the Pythagorean theorem. A squared plus B squared equals C squared. We're looking for the C. We're looking for the longest side. All right, so A squared, you could use either one for A, either one for B. So 2 squared plus 7 squared equals C squared. So 2 squared is 4, and 7 squared is 49. We'll bring down the equals C squared. And if we add together 4 and 49, that gives us 53. And to get rid of the square, we take the square root. Now, let me just bring down a C on the right. 53 actually doesn't even break down. I mean, you could break it down into radical 1, radical 53, but the square root of 1 is 1. So it would be 1 radical 53. So I'm just going to leave it as radical 53. Okay, this is a number that, I mean, you could give it a try, but you're not going to be able to break it down. So I'm going to leave this as radical 53. Okay, now if we come over here, they want us to find cosine of A and cosecant of A. So let's start with cosine of A. Okay, so since we are in the second quadrant, right, we know cosine is negative here, right? Sine is the one that's positive there. So since cosine is negative, I'm going to write negative and then adjacent over hypotenuse. So just look at the triangle and plug them in. So this is going to be equal to negative, the adjacent is 7, and the hypotenuse is radical 53. Okay, and then we have to find cosecant of A. Now, cosecant is the reciprocal of sine. So let's first find sine of A, and then we'll flip that answer upside down to find cosecant. Now, in the second quadrant, sine is positive. So sine of A is going to be equal to positive opposite over hypotenuse. Okay, so the opposite is 2, and the hypotenuse is radical 53. Now, that's not what they wanted us to find. They wanted us to find cosecant of A, right? And cosecant is a reciprocal of sine. So if we want to find cosecant of A, super easy. All we have to do is just take this fraction and just flip it upside down. Okay, it's equal to the reciprocal. So this is going to be radical 53 over 2. All right, and that's it. Okay, and then finally number 9. Given that sine of theta equals negative 5 over 11, and theta is in quadrant 4, use the identity, sine squared plus cosine squared equals 1, to find the exact value of tan of theta. Now, normally you could draw out a bow tie triangle, right? Opposite over hypotenuse, solve for the missing side, and use that to find tan. But it says here we have to use the identity. So in this one, you have to use the identity. Okay, so they tell us that sine of theta equals negative 5 over 11. So this doesn't just say sine of theta, it says sine squared of theta. So I'm going to replace the sine of theta with negative 5 over 11, but then we have to square it. Okay, and then I don't know cosine squared theta, so I'm going to bring that down, and we'll bring down the equals 1. Okay, so when you square a fraction, you just square the numerator and square the denominator. Now, first of all, a negative times a negative is a positive, right? And then 5 squared would be 25. And then if you take the denominator and square it, 11 squared is 121. Okay, and then I'm going to bring everything else down. Now, I'm trying to solve for cosine here, right? I need to get the cosine by itself, the cosine squared. So I'm going to subtract this fraction from both sides of the equation. And 1 minus 25 over 121 would be equal to 96 over 121. And I'm going to bring down the cosine squared theta. All right, so now I'm at the point where I want to get rid of the square. So to do that, I'm going to take the square root of both sides. So this leaves me with cosine of theta equals, for right now I'm going to write plus and minus. Okay, so now when you take the square root of a fraction, right, you take the square root of the numerator and the square root of the denominator individually. Okay, so let me just move this up a little. So we're going to bring down the cosine of theta equals, now actually let me move this back down. Okay, it says we're talking about an angle in quadrant 4. So if you think about all students take calculus, look right here in quadrant 4, right, isn't cosine the positive trig function? So when I write this, I'm only going to worry about the positive. I'm going to get rid of this negative. Okay, and if it's positive, you don't even have to write it. So cosine of theta is equal to positive. Now, we have radical 96. Let me simplify that off to the side. So radical 96, that would break down into radical 16 times radical 6, which is 4 radical 6. Okay, 16 is the biggest perfect square that divides evenly to 96, and that would leave me with radical 6 left over. And since the square root of 16 is 4, we get 4 and bring down the radical 6. Okay, and then this right here, the square root of 121, is just 11. All right, now that's what cosine of theta is equal to. Let me just label this part A, because we're still on part A, right, for a little bit. All right, now what they want us to find in part A is the exact value of tan of theta, right? So we're looking for tan of theta. All right, now we know that tan is equal to sine over cosine, right? So if we want to find tan of theta, we're going to take what sine of theta is equal to, which they gave us up here, right? Sine of theta is equal to negative 5 over 11. And then cosine of theta we just found to be 4 radical 6 over 11. Okay, and then we've learned that when you're dividing two fractions, right, if they have the same denominator, you can just cross those denominators off. So that's going to leave us with negative 5 over 4 radical 6. Okay, I'm going to bring this tan of theta down too. So this is our final answer for part A. This is what tan of theta is equal to, negative 5 over 4 radical 6. All right, now for part B, all they want us to do is figure out what this is equal to the nearest hundredth. So all you're doing is just plugging this in your calculator. Here, let me do this A and this B. And we're just going to round that answer to the nearest hundredth. All right, so tan of theta equals, and in my calculator, to the nearest hundredth, I get negative just 0.51, so 0.51. Okay, and that's it.